Hello, I'm afraid this is one of my slightly longer recordings, but it's so that I can get through a number of concepts which are quite important for you to understand when you're collecting quantitative data. So as you can see from the plan, this is what I'm going to go through: the different types of quantitative data, so nominal, ordinal, interval and ratio, normal data distribution and the parametric and non-parametric statistics, and organising and coding data. So this is briefly going to introduce all of these, so it'll put you in a better position when you come to do some quantitative data analysis. So first of all, when we look at types of quantitative data we get, they're classified using a hierarchy of measurement that goes from nominal through to ratio data. What you will find is in SPSS, which is the statistics package that we use for analysing quantitative data, particularly from questionnaires, interval and ratio data are linked together and called scale data. And basically the kind of data you have dictates the techniques you can use for presentations, for summarising and analysing data. So it's quite important you understand which kinds you have, because otherwise you just make silly mistakes. And also in SPSS it won't allow you to do certain kinds of analysis if you've classified it wrongly. So first of all, nominal data. We get a lot of nominal data in questionnaires. So nominal data puts things into named categories. So for example, mode of transport. So it's named as car, bus, train here. Types of beer. Music genre. These are all named categories. The category is not numerical, but you can count the number of people in a particular category. So as example, I've got 200 women, 55 prefer to drink lager, 35 prefer to drink bitter, etc. So you can count them, but the actual data itself is just a named category. Then we have ordinal data. Ordinal data, here we use numbers to put objects in order. Okay, but one of the issues is there's no information regarding the intervals, the differences between the points on the scale. Now the classic one here, which many of you will use, because we use this a lot in questionnaires, is something like the Likert scale, where we've got statements that measure attitude. So typically here we use strongly agree, agree, neutral, disagree, strongly disagree. So they're in an order, okay? But actually, when someone's answering a question, we don't really know how far they see strongly agree being away from agree and away from neutral. Okay, it's fairly subjective, but the data is ordered, and typically we would code that data from 1 equals strongly agree through to 5 equals strongly disagree. So a little bit more about coding in a moment, but we'll give it a number code. And that enables us to do some more sophisticated analysis than we can do with the nominal data. So this is a classic ordinal scale. To what extent would you describe yourself as the following? Okay, and we've got it on this kind of strongly agree to strongly disagree scale. So you've seen this fairly often in a questionnaire. Then we have interval or ratio scale, or ratio data, which is called scale data in SPSS. Now we don't normally get a lot of this kind of data from questionnaires, but if you're using data like you've got tourism arrival figures, you might well have interval or ratio data. If you've got numbers of sports participants, you might have something that's interval or ratio data. So basically this kind of data has a numerical quantity. So I've got some examples there, like age. If people tell you their actual age, they say they're 26, it's a numerical quantity, and we know what that means relative to someone who's aged 15 or someone who's aged 56. Other things you might capture in a question might not be length of stay, how much people spent. These are all ratio data because 0 means nothing of that variable. So they go from 0 to, well, in theory, infinity, although people obviously don't live that long. Then we have things like temperature, so say temperature in Celsius. This is interval data because 0 Celsius doesn't mean absence of heat. Okay, so we don't tend to get a lot of that kind of data in questionnaires. So an important point I've put at the bottom there, if you decide to group any data that's been captured within interval or ratio scale, so you've captured people's age by just asking them to state how old they are, and then you put it into categories, it then becomes nominal data. Okay, so I wouldn't normally do that, but sometimes it can be quite helpful for some comparisons to do that and put that in as an extra variable when you're dealing with your data in SPSS. Okay, and then once you know the type of data you've got, that will actually determine to a large extent different analysis options. So on the left-hand side there in that first column, I've got various kinds of analysis that you might do in SPSS. And depending on the kind of data you've got, it may be more or less viable with that for that analysis. So, for instance, if you have nominal data, which we tend to get quite a lot of, you're quite limited in the statistical tests that you can do. Ordinal data is a bit better, more powerful data. So I always try to encourage students when they're designing questionnaires to think how they can use ordinal data as much as possible or generate ordinal data. Next thing we need to think about is normal data distribution and then whether our data is parametric or non-parametric. So if we looked at some assignment grade distribution, this is one from one of my assignments some time ago, you'd normally expect there to be a fair amount of bunching sort of in the middle, perhaps around 60%. And what I've put on here in the blue line, that is the normal, the distribution line. And what you can see is it's a bit peaky just before 70%. So there was quite a large group of students who got marks sort of in the mid to high 60s. But also there was quite a peak as well at the sort of top end of the 40s. Okay, so it's a little bit messy. It's not all grouped around one average grade. And when we talk about normal distribution in an ideal world, our data would be symmetrically scored around the centre of all the scores. Now you can see with my assignment grade distribution that's not the case. Okay, and this is typically because you get quite a lot of good students who are working hard who get marks in the high 60s, but then you get some weaker students, some students who haven't really put much effort, so you sometimes get a peak lower down in your assignment grade distribution. Now if you've got this symmetrically distributed data, you have what's known as a normal distribution, and this is characterised by a bell-shaped curve. So this is a classic bell-shaped curve. Now if you measure various things in day-to-day life, like for instance people's height, then you will see that it tends to fall into a normal distribution. So a lot of naturally occurring things like height will fit in that. It would also apply to something like body weight. You would have a normal distribution of that. So you'd have relatively few very light people, relatively few very heavy people, but a lot of people clustered around an average. So this is quite useful to know whether your data is normally distributed, because basically it can help us determine whether we have parametric or non-parametric data. Now, first of all, if you've only got nominal and ordinal data, it's going to be non-parametric. Strictly speaking, it is only non-parametric. Sometimes we can treat some ordinal data as parametric, but generally I teach it as non-parametric statistics. Now, if we have scale data, that's interval or ratio data, we can generally treat it as parametric, but we would normally check it's normally distributed first. Okay, so we'd do some checks if we had our data in SPSS to make sure that's the case. And, we'd be looking for this kind of symmetrical distribution curve. So just to give you some examples of nominal, ordinal, interval and ratio data and how this links to whether it's parametric or not, I've got some questions here. So these are quite event focused, so if you're an event management student you could apply this, but obviously this could be relevant to sport management and events, or hospitality and events you might host at a venue, or tourism as well. So the first one is, which event did you attend? It's a named category. They went to the concert, they went to the poetry reading, they went to the circus. It's nominal data. It's categorical data, it's non-parametric. Then you've got something where people, reflect on a sort of an ordinal scale. So was the sound very good, good, poor, or very poor? So this is ordinal data. Okay, it orders people's perception of that sound. And it's basically categorical data that's in a ranked order, and it's also non-parametric. And then you probably wouldn't ask a question on this, but you might measure for some reason the temperature at the event, and you've got a temperature in degrees centigrade. And this would give you interval data. This is scale data and would normally be parametric. And then if you ask people to state their age in years, this would give us ratio data and also all scale data in SPSS, and it's parametric. So it tells you, straight away what kind of statistics you need to look at. And in the textbooks, you'll find they sometimes have a section on non-parametric and parametric statistics. So one thing we're going to do, once we've collected data from a questionnaire, we need to organise and code that data. Now, if you've collected your data using an online survey tool, it will be automatically coded for you, but you may need to tidy up some of that coding, but it will be done automatically. So first of all, we need to just think about the relationship between questions and variables. So variables are the unit that we are measuring. Now, one complication that sometimes causes students concern is if we ask 20 questions on a questionnaire, that doesn't necessarily mean there are 20 variables. So typically when a student distributes an online questionnaire and gets it back, they come and see me in a panic and say, I asked 20 questions, but I appear to have 100 variables. Something's gone wrong. Well, I can explain why. So here we have a question. To what extent would you describe yourself as the following? Student sees this as one question, but actually it's generated 10 variables because each of these answer options, or each of these options, inventive, creative, organised, is actually technically a separate question. So they think it's one question, but actually there's 10 here, and that generates 10 variables. So you would have a variable on each of these, inventive, creative, organised, etc. Okay, so that's one of the things that you'll see happening. Then the other thing is it depends how you've asked certain questions. So whether when people are selecting an answer option, they can only select one, as in the case here, please tick one box. That question will create one variable. However, in this one, where we're asking about the activities and interests they'll pursue on a visit to Weymouth and Portland, it says tick all that apply. So actually, potentially, someone could tick 10 of these. And what you will see here is if you do an online survey, this would generate a variable for each of these answer options. And basically, it would indicate whether people had ticked it or not. So it's basically, did they tick that or not, would be what comes out as in the coding. So again, that often causes students a panic. I've got this question and suddenly it's been split up. So if you do ask people to tick all apply, bear in mind that they'll present the data as a separate variable for each one, which can sometimes be very helpful, but it's worth reflecting on whether you want to know what was the most important activity for them, or just you want to know all of the ones they did. Okay, because if you want them to know the most important one, you need to change the question wording to reflect that and just get them to answer one of the options. Coding closed questions is pretty easy. So we will use numerical codes, and when you download your data from online survey tools, if you use the JISC survey tool that we recommend that is free for Bournemouth University students, it will automatically give it number codes and it will generate an SPSS file for you. If you're using another tool like SurveyMonkey, it will not necessarily do this automatically. It will put things in words. You will have to ask it for the numeric codes. It's one of the options for the download. And then it will do that for you. If you're entering the data yourself, we will enter the data with a number code. Now, if you've got interval and ratio data, it's already a number. So, for instance, you've asked people their age and they've said they're 26. It's a number, so we just enter that number. But for categorical and ordinal data, we will also give it a number code. So that's something to do afterwards if you've handed out a questionnaire and you actually need to enter that data. So if we just have a look at what happens when that's the case. So I've got an example here where I've done some coding. So I've got different respondents there. I've just used their names so I can pick them out for you. But you wouldn't normally collect their name. But so if we look at Roger, he's told us his age is 25. Now, if we'd put that in categories, so imagine he had some answer options to complete and we'd given some categories of 18 to 24, 25 to 30, 30 plus, Roger would have ticked 2. Okay, so he'd have ticked that second one, 25 to 30. And we're going to code that as 2. And when you set up SPSS files, as you'll see in workshops, you can tell SPSS that when you enter number 2, it means 25 to 30, and we set that up at the start. And then they've attended 2 different types of event, and we want to know which one they've attended. So 1 is coded as the food festival, 2 is coded as the rock concert. And it saves us typing in 18 to 24, food festival. So it makes data entry much quicker. So, that's an important part of it. And also, going back to, getting your data from online surveys, we want the data in numeric codes because it enables us to do some further analysis that we wouldn't be able to do with ordinal data without it being a number code as well. So we always want to make sure we get the numeric data when we download data sets. We also code missing data, so sometimes people don't answer questions. Okay, so it may be that that respondent isn't required to answer that question, so they've been told not to answer it. In other words, your survey will route them past the series of questions that don't apply to them because of the way they've answered an earlier question. Sometimes people refuse to answer a question. They just don't have an answer, they don't want to answer it. Sometimes they have no opinion, and sometimes they just miss it by mistake. Now, actually, one of the nice things with online surveys is you can actually force answer responses. So you avoid some of these problems of people missing things by mistake. But you will sometimes still get missing data. Now, when you download data from these online systems, it will often leave it blank. Sometimes we have to go in and enter missing data codes, not always. I typically code with 9, -9 or 99. It just depends how many answer codes I've already got. If I've already got 9 codes that have been used up by all my answer options, I'll code it as 99. Open questions. SPSS is not good at open questions. It depends what the purpose of your open questions are. If they're just to actually give you a little bit of insight, more qualitative insight into the way people have been answering the questions, you won't need to analyse them in SPSS. You want to just sort of make a note of those answers and actually look for some interesting, answers that people have given, some explanations they've given. But you can actually code them. You have to create closed answers from the open questions. So you're going to turn it back into a closed questions by looking for what patterns there are, what things people have said, and then perhaps coming up with a coding list for them. So it's quite a lot of work. It's only worth doing if you've got quite a lot of people who've given fairly similar answers. So here's an example where an open question was coding. These were the main factors indicating preference for communication means. And, so the first one here was looked at was face-to-face. And people obviously gave an open answer about why they preferred it, and then this has been coded into interactivity, preference, personal contact, security and trust, etc. So someone's gone through all those qualitative questions and said, okay, so this answer is all about interactivity, coded it as that, etc. So it's quite time consuming. It can be quite useful. I use open questions a bit because I do quite inductive research using questionnaires, but you have to be prepared to put in the time to code the answers. So that's a bit of a rapid overview. If you're feeling lost about this, it's really important that you go and read around this topic if you're using quantitative data analysis. The Saunders book, chapter 12, is very good on this. It's available as an ebook. I've also loaded some data analysis worksheets onto Brightspace, and these refer to some of the statistics as well that I'm going to cover in later sessions. So it might be worth having a read through them. They're a little bit like a textbook's entry on those topics. And if you're doing quantitative data analysis, you want to make sure you attend the SPSS workshop.